Assalamu alaikum. Hope you all are fine. In this video, we will learn about the E1 and E2 reaction mechanism. So firstly, we will discuss about the E1 reaction mechanism in which an alkyl halide that dissociate and form a carbocation. And from this carbocation, the water that acts as a base removes a proton from the carbocation, and in the result, there is a carbon to carbon double bond. And Due to this proton leave when the proton leaves, there will be a pi bond that is formed, and as a byproduct, that is a hydronium ion that contains a positive charge. And this mechanism shows that an even reaction is a two-step mechanism. In the next slide, we will talk about the even mechanism. So in the first step, ionization of C and carbon and halogen gives a carbocation intermediate. So in the first step, the bromine or halogen will leave, and as a result, the carbocation intermediate forms. And this carbocation intermediate has a positive charge, and the bromine that leaves has a negative charge, because bromine takes electron from the alkyl group, and from alkyl group there is a deficiency of electron. So basically, in the second step, proton transfer from the carbocation intermediate to a base, and in this case, the solvent, and because of the solvent, and that solvent contains a nucleophile that will attack and on the carbocation, and will takes a proton from carbocation. And in the final, we have a double bonded carbon to carbon compound that is alkene. So basically, this is the mechanism of even, and it is a two-step reaction. So first step is rate determining, that is a slow step, and the second step is a fast step, in which the final product is alkene. So the next is E2 reaction. It is a single step mechanism in which the rate depends upon the alkyl halide and base. So basically, in the E1 mechanism, the reaction starts with the alkyl halide only, but in the E2 reaction, the rate depends upon the alkyl halide and base, the both. It will depend upon both alkyl halide and base, because the reaction starts with these two reactants. So firstly, we will take 2 bromo 2 methyl propane, and it will react with a hydroxyl group that is a nucleophile, and the it is a one step mechanism, so we get our final product, that is alkene. And in this reaction, that is 2 methyl propene, and we get byproduct water and a nucleophile. So basically, the hydroxide cannot act as a nucleophile in this reaction because of the bulky tertiary halide. Rather, hydroxide act as a base and abstract a proton. The next is the mechanism in which we have sodium positive ion, and the ethyl group with the oxygen that is partial negative charge. So it is a one step mechanism in which the hydrogen removed must be anti to the leaving group. It can be understand by the way that from which side the nucleophile attack. Okay, from if the nucleophile attacks from the left hand side, so the leaving group must be on the right hand side, because if the reaction proceed and the nucleophile attack from the left hand side, and then leaving group will be on the right hand side. So when the nucleophile attack from the left hand side, it will attach and forms a bond, and in the same time the leaving group will leave from the from other side. Okay, and because of this situation, the nucleophile when attack from the left hand side, it will take the proton from the alkyl halide, and at the same time the from the alkyl halide, the halide group will leaves. So basically we have the final product, that is alkene. And the next is the difference between the substitution and elimination reaction. So in the substitution reaction, reactions involve the substitution of one nucleophile for another, simply the exchange functional group. So in the substitution reaction, one group, as we take an example as a nucleophile, when the nucleophile attack on it, it will replace the other nucleophile that is weaker than itself. So in the elimination reaction, the removal of original functional group results in the formation of double bond. So in the elimination reaction, from one carbon, the nucleophile will take a proton, and from other carbon, adjacent carbon, there is a halide group that will leave at the same time. And due to this elimination reaction, the carbon to carbon pi bond will form. So in the next we will see the difference between the elimination and a substitution reaction. So there are some factors, conditions, and favors, and we will see if the reaction is elimination reaction or substitution reaction. So firstly we will see the factor type of halogenoalkane, most important factor. So this is the most important factor, and when the one order reaction or 1 degree reaction that contains one halogen group in its side, so it mostly favors the substitution reaction. When it is a second degree reaction uh, or halogenoalkane, and it is either the elimination reaction or the substitution reaction. And when the halogenoalkane forms a third order reaction, and third order means it will have three side halogen or alkane, and it will mostly be a elimination reaction. And when the factor is a solvent, and in the solvent, the water is a solvent, and it will undergo the substitution reaction. And if the solvent is ethanol, that is a non-polar solvent, and it will undergo elimination reaction. And because the factors are we studying, and temperature is also a factor, and at high temperature elimination reaction occurs. And on when the concentration of base is high, the elimination reaction occurs. So these are the factors and conditions. Because of them, we will find out whether the reaction is a elimination reaction and a substitution reaction. So this is the end of the topic of E1 and E2 reaction mechanism, and we also see the difference and some factors and condition that regards the elimination reaction and substitution reaction. So thank you so much, take care, Allah Hafiz.